Okay, now we're going to make an angle bisector. So take the second paper, the second half of your paper, and grab your ruler, and I want you to make an angle. It could be whatever kind of angle you want to, but please use your ruler to make it. Okay, so you have an angle in your paper. Now we're going to make an angle bisector. So to make an angle bisector, we're going to split this angle in half. Now, if you think about what an angle bisector does, it's going to be a line that goes through the middle of this angle. So you're going to have a line going through here, and it's going to go through that vertex. So in order to create that, we're going to take this segment, and we're going to fold it on top of that segment. So fold this over. Make sure you see this dot right here? That's my vertex. It's got to go through that vertex. So I'm going to kind of pinch at that vertex. Hold your paper up to the light if you need to. And you see right here in mine, you'll see how they are not lined up. The segments are not lined up. In order to make an angle bisector, you've got to get those lined up. So I'm going to turn my paper until I get those segments lined exactly on top of each other. And then crease it. And when you open it up, see mine's off a little bit, but you should have a crease going straight through the middle of your angle. Okay, I'm going to try to make mine a little bit better. Okay, that one's better. That one actually goes through this vertex. Okay, now I want you to take your ruler and trace that crease. Don't trace this part back here, because when you draw an angle bisector, it doesn't show up behind the angle, only in front, in the middle of the angle. So take your ruler and trace that crease that you just made. Okay. And what you've got is a line that's going straight through the middle of your angle, which means this angle is congruent to that angle. Okay, so draw an arrow to this. This is an angle bisector. Okay, now there's something else about angle bisectors that I want you to know besides that it cuts an angle in half. I want you to put a point anywhere on this angle. I don't care where. But just put a point anywhere on this angle bisector. I'm going to put mine right there. Okay, now, there's a little physics lesson for you. If I take this pen, and I have it right here, y'all can see I'm holding it up, and if I just drop it straight down, I don't throw it, I don't push it, I just let go, it's going to hit my desk at a 90-degree angle, right? Okay, so that is what, when you're trying to find the shortest distance from a point, so the point I'm holding this pen at, to the ground, from this point to the ground, the shortest distance is going to hit the ground at a right angle. It's going to go straight down and hit at a right angle. So if I'm trying to find the distance between this point and this side right here, the shortest distance from a point to a side is going to be a straight line that hits it at a right angle. So if I were to draw this line right here, you see how this line's slanted? That's not the shortest distance between this point and this line. If I turn it this way, that's a little bit closer, but that's still not the shortest distance. To get the shortest distance, I've got to make a right angle. So the corner of your ruler is actually a right angle right here. So we're going to use that right angle. Make your flat bottom of your ruler even with this side. So don't do it like that. Keep it even with this side. Make sure it goes through the point that you selected. And then I want you to draw this segment and show that that's a right angle. So what you just drew represents the shortest distance from this point to that side. Now turn your angle over and you're going to do the same thing on the other side. From this point to this side, we want to draw the shortest distance. So again, we're not going to line it up like this. We're going to line up our bottom of our ruler even with the side. Make sure it goes through our point, and then draw the line that goes straight down and makes a right angle. And then if you fold this on your crease that you made earlier and look at those two segments you just made, you should see that those two segments are the same length. Like if I hold this up close, you guys can see how the other right angle is on that side. So these two segments are the same length. So open it back up, and I want you to put a tick mark here and a tick mark here. This is true for any point on this angle bisector. If I put a point right here on this angle bisector, it's going to be the same distance to this side as it is to that side. So anywhere I put a point, I've got the same distance to the sides. So what I want you to write over here is any point on the angle bisector is equidistant. That means same distance to the sides of the angle. Now, we have talked about two different things so far. We've talked about perpendicular bisectors and angle bisectors. Now, here's the point of both of these. Let's go back to perpendicular bisectors for a second. If I have 2 points and I want to find another point that's the same distance from A and B, why would anybody care about that in real life? Well, think about it. I want you to picture 2 locations, like maybe 2 cities or 2 places, like where you live and where you work. Why would you want to find a place or a location that's the same distance from where you live and where you work? Or where you work and where your kids go to school? If you put a house at point D, like if your house is at point D, then you could have the same distance to your work as it is to where your kids go to school. Or if there is a hospital, if there's a hospital that wants to serve 2 cities, here's city A and city B, the hospital needs to be the same distance between both cities so it can serve them equally. Or if there's a cell tower, if they're trying to put a cell tower somewhere, that it's the same distance from 2 areas to serve them equally. All of these use a fact of the perpendicular bisector, that any point on the perpendicular bisector is the same distance from 2 points. Okay, now angle bisector. Angle bisector is the same distance from 2 sides. Well, let's say these sides are roads. If this is a road and this is a road, why would we want to find the place that's the same distance from 2 roads? Well, if you're trying to find like where to put a Walgreens or something like that, you might want it to be the same distance from 2 roads. If you want a hospital, like if this is I-85 and this is Highway 60, you want to find maybe put a hospital where the emergency room is the same distance from 85 and 60 so that the ambulance has a direct access to 60 and direct access to I-85. So there's things like that people, that engineers use to plan roads and plan locations to build things and plan cities. All of this is used in that. So what we're learning this unit is going to apply with perpendicular bisectors and angle bisectors. And then there's 2 other segments that we're going to learn about, and we're going to talk about what those have to do with centers of triangles. Okay, so in the next video, you're going to learn about your first triangle center.